In today's lesson, we're going to continue to use the sine function, but as opposed to last lesson where we found angle measures using the sine function, in today's lesson we're going to find side lengths using the sine function. The directions here ask us to use the sine function to find the length of a side of a right triangle, and then we're asked to round our answers, which you'll typically be asked to do anytime that you're solving a trig problem. If you notice in all the examples, we're given an angle measure, we're given a side length, and we're asked to find the length of a side of the right triangle. So in part A, we have this angle measure of 62 degrees in the right triangle. We're asked to find the length of the opposite side, and we're given the length of the hypotenuse. Whenever we're using the opposite side and the hypotenuse of a right triangle, we need to be prepared to use that sine function and write down the formula where the sine of the angle is equal to the opposite over the hypotenuse. Then we'll substitute in and say the sine, in this case of 62 degrees, is equal to the opposite x over the hypotenuse, 22. My goal is to solve for x, so I'm going to multiply by 22 on both sides, and I put that in my calculator. When I put it in my calculator, I have to make sure my calculator is in degree mode. If you're in radian mode, you will get an incorrect answer. So I'm going to put 22 sine 62 in my calculator, and the directions tell me to round to the nearest hundredth, and I'll get 19.42. And that's a length, so it does not get degrees with it. In part B, I'm given the hypotenuse is 12. The side opposite the 40 degrees is what I'm asked to find, that's my x, and my angle measure that I'm giving in my right triangle is 40 degrees. Again, opposite and hypotenuse, so we have sine of the angle equals opposite over hypotenuse. When I substitute in, the sine of 40 is equal to the opposite x over the hypotenuse 12. To solve for x, I multiply by 12 on both sides, and then I type that expression 12 sine 40 into my calculator, and end up with 7.71. In part C, given the opposite's 5, the hypotenuse is x, and the angle measure is 24 degrees. Whenever we have opposite and hypotenuse, we use sine, so the sine of the angle is equal to opposite over hypotenuse. When I substitute in, sine of 24 equals opposite 5 over hypotenuse x. My goal is to solve for x. So to solve for x here, I chose to make this a proportion and then cross multiply. When I cross multiply, I'm a big fan of cross multiplying up. So the x times the sine of 24 gives me x sine 24. 1 times 5 is 5. My goal is to solve for x. So I'm going to divide by the sine of 24 on both sides. When I put 5 divided by the sine of 24 into my calculator and round to the nearest hundredth, I get 12.29 degrees. Or that's not degrees, it's a side length. There are no degrees with that. In part D, I'm given that the opposite is 13. I'm given the hypotenuse is x, and I'm asked to find the hypotenuse. The angle measure that's given is 68 degrees. Again, opposite and hypotenuse, so I know it's sine. So I write down my sine formula. Sine of the angle equals opposite over hypotenuse. Sine of 68 is equal to 13 over x, 13 being the opposite, x being the hypotenuse. My goal is to solve for x, so I chose to put sine of 68 over 1 and cross multiply. X times sine of 68 is x sine 68. 1 times 13 is 13. I divide by the sine of 68 on both sides, round to the nearest hundredth, and get x equals 14.02. Good luck trying some of these problems on your own.